Okay, good morning, everyone. Sorry I couldn't be there today. If you haven't done so already, make sure you take the 9-4 quiz. I should have 15 minutes to take that. Once that is over, we're going to start these notes on chords. Okay, so last class we talked about a tangent to a circle. And just to remind you of what that is, we have a circle and we have one spot on the circle where a line touches. That is tangent. But today we're going to deviate from that. We're going to have a circle, and the circle is going to get hit in two spots. These are called endpoints, where those points are. And those 2 points are what we call a chord. So a chord touches in more than one spot. A chord is a segment whose endpoints are on the circle and they touch twice. Today's math, though, is going to be very easy. A lot of what's going to happen is just reflections, mirroring. So first off, here's a picture, and if you look at the picture, we have four things that are marked the same. Well, all of those are radius. So yeah, all those radius are the same. And then a lot of what we see today is from last semester. If you notice right here, we have vertical angles, and we have two triangles that are now marked congruent. How? Well, the triangles are congruent by side angle sine. Now, remember what we said last semester. If you had an iPhone 16 and somebody else had an iPhone 16, both of those phones are congruent. You could then look at individual parts and you could say, well, the camera on my phone is the same size as the camera on the other phone, right? They're identical models, so things have to be identical. Well, now that we know the triangles are the same, they're asking is the chord RS going to be the same as the chord TU? Well, yeah, if you folded those triangles on top of each other, those two pieces have to fit because they are congruent. So we would say yes by CPCTC. If you remember that from first semester, corresponding parts on the congruent triangles are congruent. If you look at this other circle, we have two triangles. This is a radius right here. It's going to let me draw it in. That's a radius, that's a radius, that's a radius. So all of these are the same. And if you notice, the triangles are congruent by side, side, side. So again, if we were to take those two triangles that are the exact same and fold them on top of each other, we would observe this angle is the same as this angle. And so we would say yes again by CPCTC. And that leads us into one of our theorems today. If you have two chords that are the same, then the angles that they meet on are the same. So we're going to be looking for that in today's picture. The other theorem is going to talk about arcs. Now, in case you forgot what an arc is talking about the crust. So they're saying if we take this arc into M and it's the same as this arc, P to Q, so they could give you something like, oh, this one's 60 degrees. Oh, this one's 60 degrees. If they're both the same, then the chords that are on them have to be congruent. NM would have to be the same as PQ. So that's one of the theorems. If you see part of the arcs that are the same, then the chords that they're on have to be identical. Okay, when you're ready, flip it over to the next page. We're going to start the examples. Today's going to be very simple and basic. Okay, if you have a segment that comes from the center but doesn't go all the way across, it's not a radius. But if that piece happens to be the same length as this piece, they're mirroring. You guys see that? And what that means is this chord DC would have to be the same length as AB. Everything's going to mirror over and they could fold on top of each other. So they're going to be the same. So, with that being said, let's look at the first example. Now, let's write what they give us. They say, look at arc AC. So, from A to C, right there, that's 43 degrees. And then it says, look at the chord that it's using. A to C right there is the exact same as F to D. So these two chords are the same. So basically, they're telling us, hey, it's mirroring. And they tell us B to P, this part is 5. Okay, that's all the information they've given us. Let's go through the picture and let's see if we can figure everything out. So the first thing they say is, what is the chord DF? So we are looking right here, this chord right here. How long is that? Well, since it mirrors, let's mirror back to the other chord. And if we can figure that out, we can figure out our question. So there's our chord. And if you look, B is in the middle right here. So the middle to C is 2. That mirrors over, so that's got to be 2. So if we put all of that together, FD is going to be the same length. So going all the way across, yeah, we should say this is 4 units. Then we're looking at AC. Segment AC is the same as FD, so 4 units. Now they say look at FE. Well, that's just half. And remember that mirrors the other side, and so we know each little piece is mirrored. So it would be 2. Now, when they have, remember the rainbow is an arc, right? So they're asking for arc DF. They want to know, what is this crust? Well, that mirrors over. That should be 43 degrees. The last thing they want to know is PA. PA is the radius. We'll call that R, right? It's this one right here. The other two sides are 5 and 2. So we're going to have to do Pythagorean theorem. Remember, Pythagorean theorem is a squared plus b squared equals c squared. The most important thing you have to remember is find the square in the triangle, go across, and that's c. So that's r squared. Everything else that touches the square is a and b. We're going to have 2 squared plus 5 squared. We'll give you a minute or two to go ahead and solve that. Get r all by itself. We'll see what we get for the radius. You'll probably need a calculator, maybe. And when you're ready, we'll come back and look at it. Okay, we got 2 squared, which is 4. 5 squared is 25. Add that up, you get 29. We don't want R squared, we want R. So to go from R to R squared, so go from R squared to R, you take the square root. Put that in the calculator. We're gonna need that decimal. And the square root of 29 is gonna be 5.39. And we'll say units. So yeah, that's as hard as it really gets. Everything is mirroring over. Just take your time with the pictures. You should be able to see that. All right, last one. We have water. And this bowl is being filled up with water, and they stop. So if I draw the circle bowl, here's the circle bowl. The top of the water goes 5 inches across. What they also tell me is that the diameter from the center of the circle to the outside, if you go all the way across there, that is 6 units. Now they're saying stick a rose in the water, stick a flower in the water. I'm not an artist, but there's my little rose. And it needs to be in at least 4 inches of water. Okay, 4 inches of water. So here's what I notice. Could you tell me the radius from the center straight down? If the diameter's 6, what's the radius? Yeah, if you cut that in half, it should be 3. But we know here we have 5 across. There's this little section right here that we still don't know. Let's put that in purple. We don't know right here. We don't know that. So we're gonna call that X. Right? We don't know that part. You need to figure that out. Let's draw this circle a different way. We'll draw here. It's supposed to be 5, but if I cut it halfway, this should be 2.5. Here we don't know this piece. And from the center to the outside, this is a radius. Well, we already said the radius is 3. So we have another Pythagorean theorem problem. X is here, 2.5 is here, 3 is here. I need you to label everything, figure out X. So label everything. What's A, B, and C? Go ahead and figure out X. Again, my advice, always look for the right angle. The right angle is pointing to C. The other two that touch the right angle can be A and B. A squared plus B squared equals C squared. 2.5 plus or times 2.5 is what? 2.5 times 2.5, 6.25. 3 times 3 is 9. Go ahead and subtract. I ended up getting 2.75. Last step, take the square root of that. 1.66 is what I got for X. When you take the square root of that. So we can put that back in our picture. And that'll go here, 1.66. Now that's the height of the water, guys. If you notice that, going from where the water starts all the way down, that's the total length. We'll call that the height of the water. And that is 1.66 plus 3. That is 4.66 inches of water. Now, they say that the flower needs to be in 4 inches of water or deeper. Well, 4.66 is deeper than 4. So we're going to say, yes, we have enough water. Okay, that is it for today. You have the rest of the time to work on the practice, and hopefully you finished up your quiz. I'll be back tomorrow. If you have any questions, you can email me until then. Have a great day.